So here we will study about the autoionization of water. So auto means self and automatic ionization of water. So autoionization is a transfer of proton from one molecule to another of the same substance. So here we can see that one water molecule can dissociate into hydrogen ion and hydroxyl ion, and if we have two water molecule, so another water molecule can accept hydrogen ion, that will become hydroxyl ion, and it can generate one more OH ion, and hydroxyl ion hydronium ion is considered as 3O plus is equivalent to hydrogen ion. So what happened here, you can see one molecule of water is another molecule of water. So basically they are showing here how this reaction is happening. So for an example, if this water molecule is transferring its proton to this molecule, it will left as a hydroxyl ion OH ion and S3O plus hydroxyl ion will form. So since this water molecule is transferring its proton to the another molecule, this is considered as a acid, Bronsted-Lowry acid, proton donor, and this water molecule is accepting the proton, that is why it is considered as a Bronsted-Lowry base, and these are the conjugate acid, base and acid of the water molecule. So this reaction is called the autoionization, where water itself act as a acid base, and usually the proton exists in the form of S3O ion. So we'll see next is the equilibrium constant for the water, how, and water is also considered as a weak acid base, that is why we are using this sign to show it exists in the equilibrium. So equilibrium constant for the water autoionization, we can write the same equation, and then in general basically what happen, we can write only one reaction, that water is ionizing hydrogen ion and hydroxyl ion, and if we write the equilibrium constant for this reaction, so equilibrium constant for this reaction, basically if you remember that whenever we are writing Kc was like product and divided by reactant. Product divided by reactant, and here we have exponents whatever is there. So for this reaction, water reaction, we are writing rather than Kc, we are writing Kw. So Kw is dissociation constant for water. This is equilibrium constant, but we call this as a dissociation constant for water, and we will write here product, which is hydrogen ion and hydroxyl ion. And since this is a heterogeneous reaction, you can see this water molecule is written as a L, a small l, pure solvent. So this will not participate in the equilibrium constant expression, that is why we are not writing divided by water. So either you can use this reaction or we can use this reaction. We can write the Kw will be hydronium ion and OH ion, or we can write hydrogen ion or hydroxyl ion. And one thing is important here, that at 25 degrees Celsius the Kw value is 1.0 times 10 to the minus 14. So this, if you remember from the previous chapter, that Kw value is very small, it means water is dissociation is very small. Hardly any water dissociate into ions. So the low value indicate that the reactant are favored, means the if you have water molecule, mostly it will remain in the molecular form, and this you have to memorize that Kw value. This is important thing to note down, that Kw is either hydrogen ion and hydroxyl ion product and will be equal to 1.0 times 10 to the minus 14 at 25 degrees Celsius. And so remember that when we were studying in the previous class, Kc or Kw here is very small than 1, and once we use this type of equilibrium constant expression questions, we usually neglect the change. So let's see the another slide here, which is related to aqueous relationship. So what it shows here, basically in neutrals there are three types of solution: neutral solution, acidic solution, and basic solution. In neutral solution, the concentration of hydrogen ion and hydroxyl ion is equal. So basically hydrogen ion concentration and hydroxyl ion concentration product is equal to 1.0 times 10 to the power minus 14, and if it is equal, then we can write that hydrogen ion raised power 2 will be also equal to 1.0 times 10 to the power minus 14, or we can also write here that hydroxyl ion concentration is square will be equal to 1.0 times 10 to the power minus 14. So there are three types of solution. Neutral solution means hydrogen ion concentration and hydroxyl ion concentration will be equal. In acidic solution, the concentration of hydrogen ion is more than hydroxyl ion. In basic solution, the hydrogen ion concentration is less than the hydroxyl ion concentration. So this is by definition. We can figure it out which one is acid, which one is base. Basic solution, right? And but in case of acidic solution, the concentration of hydrogen ion is more than hydroxyl ion. So we can also write here that hydrogen ion concentration will be more than 1.0 times 10 to the power minus 7. Or we can write it would be hydroxyl ion concentration will be less than 1.0 times 10 to the power minus 7. And on the other hand, for the basic solution, we can write here, because in basic solution hydroxyl ion concentration is more than the hydrogen ion concentration. So we can say that here hydrogen ion concentration is less than 1.0 times 10 to the power minus 7, because minus 7 he is saying, because if we will divide by 2, this will be minus 7 minus 7, and hydroxyl ion concentration will be more than 1.0 times 10 to the power minus 7. So this is the concentration, and based on the concentration, acidic solution will be there, or basic solution will be there, or neutral solution will be there. So next let's see one question, then we can understand even better. So what is the hydrogen ion concentration in the neutral solution at 25 degrees Celsius? So how we can solve this question? Basically Kw is given, So in neutral solution we know, in neutral solution hydrogen ion concentration will be equal to hydroxyl ion concentration, right? So we can write, will be, suppose this will be X. So let's work on this equation. Kw will be equal to, since we are talking about the neutral solution, so we can write here X and X on both, because the concentration will be same, and that will be equal to 1.0 times 10 raised power minus 14. So this will become X square, 1.0 times 10 raised power minus 14. So X will become what? We can take under root on both sides. 1.0 times 10 raised power minus 14, and X value will come here. Once we'll take under root of this one, 1.0 times 10 raised power minus 7. So hydrogen ion concentration will be equal to same, 1.0 times 10 raised power minus 7. So you should memorize this answer, and which is correct at 25 degrees Celsius only. Also go back to the previous slide and note what the value of hydrogen ion must be for each of the three conditions. Each of the three condition means, for acidic condition it will be more than hydrogen ion concentration than the neutral one, and for basic solution it will be less than. So here I was showing that H plus ion raised power 2. If I will find out in neutral solution H plus ion, this will be under root of this one, and under root of this one will be 1.0 times 10 raised to minus 7. So this was one example which we have solved. Let's see one more question related to autoionization of water, and that would be, this question, which is calculate the concentration of hydroxyl ion in which hydrogen ion concentration is this much, is given. So hydrogen ion concentration is given, and they are asking to calculate hydroxyl ion concentration. So what we have to do, since they are not giving temperature, so we will consider this, they are talking about at 25 degrees Celsius. And at 25 degrees Celsius we know that Kw is equal to hydrogen ion concentration and hydroxyl ion concentration, that would be 1.0 times 10 raised power 14. So from this equation, once we will rearrange, this will be OH minus Kw divided by hydrogen ion concentration. Kw at 25 degrees Celsius is 1.0 times 10 raised power minus 14 divided by this value, which is hydrogen ion concentration, 4.0 times 10 raised power minus 6. And now once we will solve this question, the math, so we will get the answer here, 0.25 times 10 raised power minus 8, or we can rearrange this one, 2.5 times 10 raised power minus 9 molar. This will be hydroxyl ion concentration. So these were the two examples for autoionization questions, and in the next video we will study about the pH scale.